Hello everyone and welcome back to Hub360 Circuit, your go-to channel for electronics tutorial, embedded systems and practical IoT projects. In today's video, we are building a smart weight measurement system using an ESP32, an HX711 Load Cell Amplifier, a load cell sensor and a Blynk IoT Platform for real-time monitoring. This system allows us to measure weight accurately and send the data to the cloud so we can view it on a dashboard anywhere in the world. Here is what we will cover in this tutorial: understanding the hardware, the ESP32, HX711 and load cell, connecting everything step by step, setting up the Blynk platform and dashboard, explaining the Arduino code, uploading the code to the ESP32, testing the system with real weight and watching live updates. By the end of this tutorial, you will have a fully functional IoT-based smart weighing system that can be applied in smart warehouses, industrial batching, agricultural feeding monitoring system, and many more IoT applications. So let's dive in and start building our smart weight measurement system. Now I'm going to connect the entire system step by step. We'll be connecting the load cell to the HX711 amplifier, then the HX711 to the ESP32 board, and then finally powering everything properly. First, I'm connecting the load cell to the HX711 module. On the HX711, we have terminals labeled E+, E-, A+, and A-. Now we will connect them carefully. The red wire goes to E+. The black wire goes to E-. The green wire goes to A+. And the white wire goes to A-. Next, I will connect the HX711 module to the ESP32. The VCC from HX711 goes to 3.3 volts on the ESP32. GND from HX711 goes to GND on the ESP32. DT, which is the data output, goes to GPIO4 on the ESP32. And SCK, the clock spin, goes to GPIO5 on the ESP32. Now, I will connect the ESP32 to power using the USB cable. The ESP32 is now powering the HX711 through the 3.3 volt supply. At this stage, the HX711 initializes, stabilizes, and performs automatic TAR as defined in the code. Now that the hardware connections are complete, the next step is to set up the Blynk IoT platform. Blynk allows us to send data from the ESP32 to the cloud, monitor weight remotely, create a real-time dashboard, and control or visualize data from anywhere in the world. This is what makes our weight system an actual IoT project. The first thing I will do is to create a new template. I click on New Template and I will give it a name. Let's say IoT weight measurement system. Next, we need to create a data stream. A data stream is the channel that carries data between the ESP32 and the Blynk dashboard. So we are sending weight data. I click new data stream, virtual pin. I select virtual pin V0. My unit is in kilogram. Can name this weight. Then my minimum value I set it at 0, and then my maximum value is 1000. You can set it depending on your load cell capacity. Then I click create. This means whenever the ESP32 send data to V0, Blynk will display it as weight in kilograms. Now I go to the device section. I click on new device. From template, and then IoT weight measurement system. This creates a physical device linked to our template. Inside the device setting, I can see the template ID, the device name, and authentication token. This auth token is very important. This is what connects the ESP32 to the specific device in the cloud. Now I copy the auth token and paste it in my Arduino code. Without this token, the ESP32 cannot authenticate with Blynk servers. Now let's design the dashboard. I click on edit, and then I add a gauge widget. I connect the gauge to virtual pin V0. Now when ESP32 sends weight data to V0, the gauge will update automatically. Optional, you can also add a label widget, a chart widget, or tracker to track weight over time. Then you click on save and apply. On your Blynk mobile app, this is how your dashboard will look like. So guys, right now I'm going to walk you through the software setup of this system. These three lines connect your ESP32 to the Blynk cloud platform. This here authenticates your ESP32 with your Blynk dashboard. Without the authentication token, your ESP32 cannot send data to Blynk. Now these are your libraries. Wi-Fi.h allows your ESP32 to connect to Wi-Fi. Blynk simple ESP32.h enables communication with Blynk using ESP32. HX711.adc.h is a library for the HX711 Load Cell Amplifier, handles reading and processing the load cell data. Now these are the Wi-Fi name and password. These store your Wi-Fi network credential to the ESP32 and can connect to the internet and send weight data to Blynk. Dout, data pin from HX711 to ESP32 GPIO4. SCK, which is your clock pin from HX711 to ESP32 GPIO5. This defines which pins your ESP32 uses to read digital weight data. Load cell, objects that communicate with HX711, reads weight and handles calibration. The Blynk timer is also an object that schedules functions like sending data at intervals. The float calibration value was 90.92. It converts raw HX711 readings into kilograms. The stable weight stores the current average weight measurement. Now, you can see here, the Blynk virtual write sends the current weight to the virtual pin V0 in the Blynk. This function is called repeatedly using the timer to update the dashboard automatically. Load cell.begin initializes the HX711 library. While this stabilizes the sensor for 2 seconds and performs automatic tar, so whatever is on the scale at startup is 0. This applies the calibration factor, so readings are in kilogram or grams depending on your scale. This averages 12 readings to smooth out fluctuations. Inside the loop, blynk.run keeps the ESP32 connected to Blynk Cloud, while timer.run runs scheduled timer functions like sending weights to dashboard. This prints weights to serial monitor every 250 milliseconds for quick debugging. Using static unsigned long, last print prevents flooding the serial monitor. Now that we have gone through the entire code and understand how it works, the next step is to upload it to ESP32. Before we upload, we need to make sure that the correct board is selected in the Arduino IDE as ESP32 development board. The correct COM port is also selected, and the authentication token in the code matches the one from our Blynk device. I am now clicking on the upload button. Uploading might take a few seconds. This is normal. As you can see, the code has been uploaded successfully. Now let's power up the system and test everything live. The ESP32 is now connected to power through USB. At this point, the load cell is setting whatever is on it to 0. So I made sure there is no weight on the load cell during startup. As you can see, the reading is now stable at approximately 0. On the Blynk dashboard, I have added a gauge widget connected to virtual pin V0. This is where ESP32 sends the measured weight every 2 seconds. So any weight detected by the load cell will automatically appear here in real time. Now I am placing a weight on the load cell. Watch carefully. You can see the value increasing gradually, and now the value has stabilized at approximately 455.158 kilograms. At the same time, notice the Blynk dashboard updating automatically. Now I will remove the weight. As you can see, the value decreases smoothly and returns to zero. This confirms that the tower function is working properly and the system resets accurately. Now let's try another weight. Again, the system measures and updates accurately. Let's also try another weight. You can see the value increasing gradually, and now it has stabilized at 74.19 kilograms. Now I will remove the weight. This shows again that the system measures and updates accurately and our calibration factor is properly set. Now, the powerful part of this system is that I can monitor this weight from anywhere in the world. As long as this ESP32 has internet access, the weight is uploaded to the cloud, the dashboard updates automatically, and I can track changes remotely. This makes it suitable for smart warehouses, LPG gas monitoring system, smart farming, inventory tracking, and industrial batching systems. In today's project, we successfully designed and built a smart weight measurement system using the ESP32 board, HX711 Load Cell Amplifier, a load cell sensor, and the Blynk IoT Platform. We started by understanding how the load cell converts the force into a small electrical signal, how the HX711 amplifies and digitizes that signal, and how the ESP32 processes the data. We then connected the system to the Blynk cloud, allowing us to monitor weight readings in real time from anywhere using a mobile dashboard. During testing, we confirmed that the load cell measures weight accurately, the HX711 provides stable and filtered readings, the ESP32 processes and transmits data successfully, and the Blynk dashboard updates automatically in real time. This project demonstrates how embedded system and IoT technology can be combined to create smart, connected measure. This project demonstrates how embedded system and IoT technology can be combined to create smart, connected measurement system. Such a system can be applied in smart inventory management, industrial batching system, agricultural feed monitoring, smart retail weighing system, and remote monitoring application. Overall, this project proves that with the right combination of sensors, microcontrollers, and cloud platforms, we can build powerful, low-cost, and scalable IoT solutions. If you found this project helpful, don't forget to like, subscribe, and share. For quality ESP32 board, HX711 modules, load cells, and other electrical components, check out Hub360 Circuit. Thank you for watching and see you in the next tutorial.